Polynomial division. Our objectives here, we're going to use long division to divide polynomials. We'll use synthetic division to divide polynomials and evaluate a polynomial using the remainder theorem. Before we start, let's define what a polynomial is. A polynomial is an expression that can be created from numbers and variables using addition, subtraction, and multiplication, including repeated multiplication. Notice that a polynomial can involve numbers and x, x squared, x cubed, etc. On the left we see polynomials, and on the right we see things that are not polynomials. When we have a square root over an x, that keeps it from being a polynomial. We see a square root here, but it's only the coefficient that is a square root. 1 over x, x in a denominator, means we're not going to have a polynomial. This is a logarithmic function. It's not a polynomial. Any rational exponents means we're not going to have a polynomial. And exponential functions are not polynomials. The degree of a polynomial. The degree of a polynomial is the highest power of x in that polynomial. Zeros of a function. A zero is an x value that, when substituted in for x, will give an output of 0. A major goal in algebra is solving equations, and solving equations is the same as finding zeros. In this equation, we start out with 2x squared plus 4x equals 3. This is the same as if we would set this equal to 0 and try to find the x values that cause it to equal 0. The main ingredients in factoring. Let's think about factoring just a number. Factoring requires two ingredients: to find a factor and to divide to obtain another factor. For example, 108 is even, so 2 is a factor. We divide by that 2. We continue factoring until we have it down to all prime factors. 108 ends up equaling 2 times 2 times 3 times 3 times 3. So in this same way, we are now going to divide polynomials. Let's start with long division. Now, dividing polynomials is like dividing numbers. We divide the lead terms, or digits. We multiply the results by the divisor and change the sign. We add and bring down the next term. Let's start here. 13 is the first number that's going to be large enough to divide by 3. So 13 divided by 3 is 4. And notice I'm putting that above the 3 of the 13. 3 times 4 is 12. Then we draw our line, change our sign, and combine down. 13 minus 12 is 1. And we carry down the rest of the numbers and repeat. 17 divided by 3 is 5. 5 times 3 is 15. So dividing up, multiplying down, draw your line, change your signs, and add down. So 2. Carry down the next two numbers. 22 divided by 3 is 7. 7 times 3 is 21. Draw our line, change our signs, and add down. 16 divided by 3 is 5. 3 times 5 is 15. Draw our line, change our signs, combine down. So we have 4,575 with a remainder of 1. Let's try this with a polynomial now. So just the same as we started out, just dividing the 13 instead of biting off the entire number, let's start out with dividing just this x to the 4th by this x. So x to the 4th divided by x is x cubed. Okay, you might think of it this way: x to the fourth divided by x. One of those removes one of those and leaves me with just x cubed on the top. Okay, so we divide it up. Now we're ready to multiply down. Now when we multiply down, we're going to take that x cubed and multiply the entire x minus 3, and that will go under here. So x cubed times x is x to the fourth. X cubed times negative 3 is negative 3x cubed. Now that we're done with that, we draw our line, change our signs, and add down. My x to the fourths go away. I have a negative x cubed plus 3x cubed is 2x cubed. We'll carry down the next few terms. That's one full cycle, and we'll repeat this process. 2x cubed divided by x is 2x squared. Make sure and separate it from the other term with a plus sign. 2x squared. And remember, when we multiply down, we're multiplying the entire x minus 3. So 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Then we'll draw our line, change our signs, and combine down. 2x cubed and negative 2x cubed cancel out. I have negative 12x squared plus 6x squared is negative 6x squared, plus my 17x minus 42 that I carry down. You notice from over here, once we get to here, we are finished. And also, this number is smaller than the divisor. So that's when you know we're finished. We're not finished yet. We have a ways to go. So I have a negative 6x squared divided by this x is negative 6x. Then I multiply down. Negative 6x times x minus 3. That gives me a negative 6x squared and a positive 18x. We'll draw our line, change our signs, and add down. My x squareds cancel, and I have a negative 1x minus 42. One more cycle. We've got a negative 1x divided by x is negative 1. Now negative 1 times x minus 3 gives me a negative 1x plus 3. Draw your line, change your signs, and combine down. My negative 1x and x cancel out, and I have a negative 42 minus 3 is negative 45. So here I have a remainder of negative 45. Let's interpret the results of a long division. If I am dividing, like the problem I did before, I have this number divided by 3. This is my quotient. This is my remainder. It actually means that 4,575 divided by 3 is equal to 4,575 plus 1/3. Now, it's interesting if we take this and treat it like an algebraic equation, even though it's just a number equation. If I multiply both sides by 3, I'll have 13,726 on this one side, and distributing from the right side, 3 times 4,575 is 13,725 plus 3 times 1/3 is going to give me 1. And this is true. So this 4,575 is actually the quotient, and your remainder over the divisor is that fraction. So when I've done long division and I end up with a remainder, this actually means that I have x cubed plus 2x squared minus 6x minus 1 plus a negative 45 over the divisor is equal to x to the fourth minus x cubed minus 12x squared plus 17x minus 42. Now, let's try some polynomial long division when we're dividing by something more than just a linear term. Divide x to the fourth plus 3x cubed plus 2x squared plus 2x plus 1 by x squared minus 2. And we'll interpret that. Make sure to leave spaces for any missing terms, and then we'll stop if the result has a smaller degree than the divisor. Let's go ahead and put our polynomial inside. No missing terms there. We have an x squared minus 2, and then we start dividing. X to the fourth divided by x squared is x squared. We'll make sure and place that in our x squareds column. Multiply down, x squared times x squared minus 2 is going to be x to the fourth minus 2x squared. Notice I left a space because we need to keep our x to the fourths in the same column and our x squareds in the same column. Draw your line, change your signs, and combine down. My x to the fourths cancel out, and I have 3x cubed plus 4x squared plus 2x plus 1. Let's round it up again. We've got 3x cubed divided by x squared is a 3x. Then I take that 3x and multiply down. So 3x cubed minus 6x. Draw our line, change our signs, and combine down. My 3x cubed minus 3x cubed cancels out. I have 4x squared. I have a positive 8x and a plus 1 that carries down. 4x squared divided by x squared is a positive 4. 4 times x squared is 4x squared, and a negative 2 times 4 is negative 8. Draw our line, change our signs, and combine down. 4x squared and negative 4x squared cancel out, and I get 8x plus 9. Now we can see what we would have to divide is smaller in degree than the degree of the divisor, so we need to stop. And our answer is going to be x squared plus 3x plus 4 plus 8x plus 9 over x squared minus 2. Now I want to introduce you to synthetic division. Here is a synthetic division with x to the fourth minus 4x cubed plus 3x squared plus 1 dividing by x minus 2. Okay, we'll go ahead and write a division box that kind of looks upside down. And inside that division box, I'm not going to put the entire polynomial. I'm only going to put the coefficients. 1 for the x to the fourth, negative 4 for the x cubed, 3 for the x squared, 0 for the x that is not there, and a 1. Now we're dividing by x minus 2. If x minus 2 were set equal to 0, what would the solution be? It would be 2. 2 is going to be the number that we put out front here. After this, the process of synthetic division is pretty simple. Go ahead and draw a line. You're going to carry down your first coefficient just so that you have something to start with. You're going to multiply that number by the 2 and put it in the next column. 1 times 2 is 2. And then combine down. -4 and 2 is -2. That's one full cycle. We'll repeat. -2 times 2 is -4. 3 and -4 is -1. -1 times 2 is -2. 0 and -2 is -2. -2 times 2 is -4. And 1 minus 4 is -3. Interpreting the results of synthetic division. Now, synthetic division accomplishes long division if the divisor is of the form x minus k, just a plain x minus k. No squares on the x, no cubes on the x, no coefficient on the x. A plain x minus k. This one is of that form, so we were able to carry out synthetic division. Now, if I had done long division on this, my answer would have been x cubed minus 2x squared minus x minus 2 with a remainder of -3. When I did synthetic division, I had these numbers at the bottom in my result. This is my remainder right here. This -3 is the remainder, and this is going to be the coefficients for your quotient. So formally stated here, the number in the lower right is the remainder. The other numbers at the bottom give the coefficients of the quotient. And that quotient is going to be 1 power less than the polynomial you started with. Let's divide 2x cubed plus 19x squared minus 5 by 2x minus 1. And we'll state the non-fraction interpretation. Now, because we have this 2 in front, we're going to have to do long division. Synthetic division doesn't necessarily replace long division, so it's a good idea for us to stay and practice. We'll set this up, and now we divide up. 2x cubed divided by 2x is x squared. Put that in the x squared column. X squared times all of 2x minus 1 is 2x cubed minus x squared. We draw our line, change our signs, and add down. 2x cubed minus 2x cubed is gone. I have a 19x squared plus x squared is 20x squared plus my 0x minus 5, and I divide again. 20x squared divided by 2x is going to be 10x. 10x times all of 2x minus 1 is 20x squared minus 10x. We draw our line, change our signs, and combine down. My 20x squared and negative 20x squared cancel each other out. I get 10x minus 5. 10x divided by 2x is 5. 5 times 2x minus 1, that's going to give me 10x minus 5. Draw your line, change your signs, combine down, and I have 0 as my remainder. So what we know in interpreting this, 2x cubed plus 19x squared minus 5 divided by 2x minus 1 is equal to x squared plus 10x plus 5, or 2x cubed plus 19x squared minus 5 is equal to x squared plus 10x plus 5 times 2x minus 1. It's interesting to note that we have no remainder shown here, and this is perfectly factored by dividing out by the 2x minus 1. The remainder theorem. The remainder theorem says that if a polynomial f of x is divided by x minus k, then the remainder is equal to f of k. So let f of x equal 2x to the 5th minus 3x to the 4th minus 5x cubed minus x squared plus 5x minus 7. Is x equals 3 a 0 of f? And if not, what is f of 3? Well, let's try. Since we have a nice plain number, we can go ahead and just use synthetic division here. Synthetic division. We like nice, quick, and easy. They've handed us the number 3 to push through the synthetic division table. I'm going to carry down my leading coefficient so that I have something to start with. 2 times 3 is 6. Negative 3 and 6 is 3. 3 times 3 is 9. Negative 5 and 9 is 4. 3 times 4 is 12. Negative 1 and 12 is 11. 11 times 3 is 33. 33 and 5 is 38. 38 times 3 is 114. Negative 7 and 114 is 107. Okay, so I see here that I have a remainder of 107. Here are the coefficients of my quotient. But the remainder theorem says that this remainder of 107 is equal to f of 3. So f of 3 is equal to 107. And we know because of that x equals 3 is not a 0. If it were, we would have a remainder of 0. So 3 is not a 0 of f of x. So let's practice on another one. We have f of x equals x cubed plus 14x squared plus 45x plus 20. Is negative 4 a 0 of f? And if not, what is f of negative 4? So we'll go ahead and set this up again. Coefficients. Making sure that we don't have any missing terms, that we need to put a placeholder of 0. Negative 4 is what we'll be pushing through. We start by carrying down that 1. 1 times negative 4 is negative 4. 14 minus 4 is 10. 10 times negative 4, negative 40. 45 minus 40 is 5. 5 times negative 4 is negative 20. And 20 minus 20 is 0. We can see we have a remainder of 0. This is our quotient, just as a reminder. But yes, negative 4 is a 0 here of f of x. And that really is because f of negative 4 is 0.